Hello, my name is Dr. Garnet Hall. I'm a vet from Perth in Western Australia, and one of my roles is to care for our nation's military working dogs. Now, as much as their attributes make them incredible canine warriors, they are not invulnerable, and unfortunately, they are occasionally injured or killed because of their service. These brave animals will often mask signs of illness until it is too late. Many instances of illness, injury, or death are preventable, as is the case with the leading cause of death outside of combat, heat stroke. It's a real privilege to do my job, but one of the things that I absolutely hate are the phone calls I receive occasionally when one of these amazing animals has sustained a significant injury or even died. On the 16th of December 2019, I received one of these calls. A young dog had been doing moderate intensity exercise with his handler in a hot environment. By the time he began showing signs of illness, even though he applied the correct first aid and took him straight to the vet, that animal could not be saved. It was too late. This was a tragic loss that had a terrible impact on the handler, as well as being a significant impairment to ADF capability. In response to problems like these, 2 years ago, I founded an Australian biotechnology company called VetChip. We make implantable permanent biosensors for animals. Our device, the VetChip, replaces the existing identification microchip that is ubiquitous in dogs in most parts of the world. It is capable of monitoring things like temperature, heart rate, physiological stress, and much more. It automatically alerts a handler to problems before or as they occur. I know this product will be of great benefit to our military working dogs in all theatres of training and war. Our device will save lives. We are keen to develop a commercial military working dog variant of our device, and we're looking for your support to do so. My contact details are at the bottom of the screen, and I encourage you to get in touch. I would love to never again receive one of those phone calls. I know that nobody wants to receive those calls, you or anyone in the chain of command. We can do our bit to save the lives of future military working dogs. Thank you.
Today, we're going to talk about how deployable fuel generation can help resolve fuel security issues for Australian Defence, the risk, a solution, and its relevance in the land domain. Fuel security is a national concern with huge potential impact. Regional instability, trade and climate policy pressure, competition with domestic and commercial demand all play into the danger that our Defence Force may be unable to deploy. 21 days of diesel in the country is an extremely worrying figure. That vulnerability and potential catastrophic impact is amplified in the context of our Defence Force when we consider the risk of being unable to deploy or the high cost of protecting fuel so that it can be delivered to a region of conflict or in crisis. Cura have developed a plan for Defence to build deployable fuel generation units and modify diesel engines so that we can eliminate geographic source as a risk to fuel supply. The fuel generation units that we plan to build can make use of any available clean water and electricity to store energy chemically in the form of ammonia, which is a well-known hydrogen-rich liquid that's already widely used internationally as a refrigerant in fertilizer. The ability for a Defence Force to deploy fuel generation capability alongside existing diesel gensets in support bases means that the cost and burden of energy sourced from high-risk fossil fuels can be drastically reduced. This strategy, which takes advantage of engines and existing assets that are expected to remain in service for decades, will allow the ADF to respond to natural disasters with a carbon-free fuel, to rapidly deploy fuel generation in theatre at a much closer proximity to where that energy is required for consumption, thereby reducing supply chain length and complexity. Further, with aid efforts and infrastructure developed and distributed during peacetime, our remote areas and our neighbouring allies can become strategic fuel reserves for our Defence Forces. Consider that Australia can become a new kind of power in our region by harvesting our abundant clean energy, storing it, and taking that energy into the field when required. Cura has developed relationships with manufacturers, researchers, and universities that will allow us to build a locally manufactured solution to this glaring and urgent vulnerability. A solution that's seen internationally by groups such as the World Bank, International Maritime Organization, Maersk, and locally by Fortescue, CSIRO, as the best option for clean bulk fuel in our future carbon-constrained environment. Please get in touch to find out how you and your group can be part of this solution.
Hi, Tamir, and I'm the Chief Investigator of RADENET, IoT-enabled surveillance system for remote hazardous environment. Hazards are around us, and some of the hazards have the potential of disaster if the response to hazard is not fast. According to the expert opinion, limited access and difficulty in operation and surveillance in remote environment are two of the main reasons of slow response. Our vision in RADENET is to develop one of the world's fastest surveillance system for hazardous environment. And for that, we are using Internet of Things, remote sensing, data fusion, and AI to achieve our goal. Our technology is based on 3D printed sensor nodes, IoT nodes, which inside them we have advanced IoT microchips with modular and reconfigurable sensor attachment to suit the need of measurement for different environments. Planning to put these sensor nodes into a protective shell, a mortar-like launcher to launch these nodes in remote hazardous environment. Upon the landing, the external will disengage, allowing the sensor nodes to have access to the environment and start measuring the required parameters and sending them to our cloud, RADENET cloud, through which data then will be communicated with our command and control station. At the RADENET command and control station, we also have the remote sensing equipment and the data and the AI and a proper user interface for to make decision and plan for the operation. Our RADENET technology will help our first responder to respond faster to the hazard, which save life, and it can reduce the damage and the natural resources we have. Thank you. For further information, please contact us at RADENET at the
The Army's greatest assets are its soldiers. It invests quite a bit of resources into their training. Robots, on the other hand, are cheap and therefore expendable. So why not use robots to reduce the risk to human soldiers? We've already developed Ground Unmanned System 1 or GUS-1 shown in the slide. This is used to monitor areas where there's animal activity, but there shouldn't be very much human activity. It's equipped with optical cameras, thermal cameras, and overhead aerial drone for a bird's eye view. It's got artificial intelligence and multiple communication channels. Its biggest disadvantage is that it lacks the traction to handle rough terrain, and it lacks the manoeuverability to avoid obstacles. We would like to develop GUS-2, which will overcome these problems by maximising traction and manoeuvrability using a novel cooperative redundant multiple steering system. GUS-2 will have 6 or 8 wheels. That means there will be either 30 or 56 steering effects, all working in unison to enforce the path of the vehicle with zero conflict. Lack of scuffing means there will be minimal ground damage, tyre wear and fuel consumption. Note that the energy required for ground damage and tyre wear comes from burning more fuel. GUS will be able to find a way through minefields, or zigzag ahead of the soldier in order to detect forward threats, orbit around the soldier to detect threats from all directions. It can carry some of the soldier's equipment. It can carry the soldier if he or she becomes wounded. It's the ground equivalent of the Boeing Loyal Wingman, or it could be regarded as a robotic combined watchdog, sheepdog, rescue dog, sniffer dog. Its sole objective is to save soldiers' lives. Thank you.
Thank you for this opportunity. Expert cognitive skills are valuable for performance in a variety of domains. My research has been to understand the expert cognitive skills of international cricket batsmen. Expert cognitive skills such as anticipation and decision-making are important for cricket batsmen because they face fast ball velocity. These cognitive skills are also important for cricket batsmen because they perform their skills under minimal error tolerance. For example, the batsman needs to make a critical decision whether to play or leave the ball, or they can go out. Anticipation is defined as the pickup of cues from the field placing and bowler's action to predict the ball type that will be bowled. These cognitive skills are vital also for soldiers to be able to make critical decisions to ensure the safety of themselves, their infantry and civilians. Existing evidence and instruments from the sport domain can be used to assess athletes and soldiers. For example, you can see in the left-hand bottom panel a video simulation display. The field placing is first presented, and then the bowler runs in and the ball is stopped at the point of ball release. A black video frame is presented at the point of ball release, showing no further ball flight, and the batsman has to make a prediction whether the ball is going to the right, left, or bouncing higher. This assesses the anticipation decision-making of athletes and has been shown to improve athletes' anticipation decision-making and can also improve these decision-making of soldiers. The video display, which is known as a temporal occlusion, can be converted to a point light display, which is on your right-hand side of the screen. In this situation, intelligence information can be presented of situational positioning of enemy, and then a point light display of the kinematics of the enemy person. Thereafter, a blanking screen can be presented and the soldier required to make a decision of whether to shoot or not shoot. And this can be used to assess and improve the decision-making skills of soldiers. Conducting research to improve the cognitive skills of soldiers can enhance their performance and decision-making. Thank you.
Hello, my name is Udo Bach. I'm a professor at Monash University in the Department of Chemical Engineering. The main focus of my research group is the development of novel printable solar cells. Recently, we have discovered a new class of conductive materials as a byproduct of our solar cell research. In this video, I would like to briefly introduce this new technology. Our everyday lives are increasingly dependent on electronics. Modern cars, for example, use up to 150 microprocessors in every vehicle. The dependence also affects the defense sector and brings about certain vulnerabilities. Strong electromagnetic pulses can be used to destroy electronic circuitry. This provides a strong incentive to protect vital electronics by electromagnetic shielding. We believe that the conductive paint we have developed in our labs can be used for such electromagnetic shielding applications. Currently, a number of conductive paints are available on the market. Each of them have their own set of drawbacks. Silver paints are very conductive, but also very expensive. Carbon and conductive polymer-based films often suffer from poor adhesion, while carbon nanotubes are very conductive, but also suspected of causing cancer. Our team at Monash University has recently discovered a new class of conductive materials from which we can form tough, conductive, strongly adhesive films on a variety of substrates such as metal, glass, plastic, textile, and paper. Our material can also be used to produce conductive semi-transparent films. The conductivity of our films is comparable to the best conductive polymers, while our coatings are made from very low cost, abundant, environmentally benign starting materials. They have a range of exciting properties and potential applications, which we only now are starting to explore. These include sensing, energy storage, thermal and pack. Recently participating in D-Star Ignite, the Defense Support Group and CSRO initiative. Here, our motivation is to gain a better understanding of the relevance of our materials for the defense sector. Our current goal is to find partnerships through which we can further evaluate the potential use of our materials with electromagnetic shielding and stealth applications as our prime targets. Our long-term goal is to find partners and pathways through which we can commercialize our product. Our team at Monash University is looking forward to discuss possible collaborations with you.
On the battlefield, one of the most crucial senses for a soldier is their sense of hearing. Hearing warns our warfighters of impending danger and allows them to listen to friend or to foe. Hearing is vital to a soldier's situational awareness, especially when danger is not visible. But sadly, hearing loss is a huge problem for our soldiers, with high risk to hearing from impulse blast, noise from military equipment that is way beyond civilian noise exposures, and hearing protectors are often insufficient. Over 30% of our returned soldiers suffer permanent hearing loss, and this costs more than $1 billion to the Australian economy in terms of ongoing treatment. Hearing loss reduces combat effectiveness, situational awareness, leads to early separation of troops, loss of skills, and endangers lives. I've worked for 30 years on hearing loss and was disheartened to learn that virtually no research is being done on hearing loss and detection in our warfighters. There is no hearing test regime or equipment suitable for use on the battlefield, especially in a noisy environment. Soldiers may have their hearing tested on return from deployment, but that is often simply too late. Soldiers in command may be unaware of hearing loss, putting themselves and their colleagues at risk. What we need is a rapid, battle-ready hearing loss detection system for soldiers on active duty, particularly after blast or noise exposure. We're experts at hearing loss detection and know how to assess hearing using the latest research and are developing precisely this technology. Using state-of-the-art sensors, we're developing a portable, wireless headset capable of rapidly and objectively assessing hearing loss in seconds by detecting the health of the inner ear and hearing brain. Information about the degree of hearing loss and the nature of it can be determined without need for clinical expertise and be done via telehealth. We've developed and tested earlier prototypes on Australian Defence Force bases, and we aim to develop to market our novel platform tailored to Defence Force needs. With over 45,000 Australian and 500,000 US personnel in active service, this represents a substantial market. So hearing loss is a huge problem for our warfighters. We strongly believe we can and need to do a lot better at improving the hearing safety of our soldiers. We believe in protecting the warfighters that are protecting us.
For over 7,000 years, humanity has been digging up metal resources and melting them into metals. Those metals have a synergistic connection with humanity's evolution on this planet, from the very first experimentation with smelting copper to creating works of art with precious metals through to the Bronze Age and Iron Age. Following the 12th century Renaissance and rediscovery of science played a significant role in creating the foundations for modern metal manufacturing, by alchemists experimenting with blending of elements to form homogeneous metals. Fast forward to 2021, and it may surprise people that even with the advent of digital technology, humanity is still utilising the same 7,000-year-old process and melting metals and fabricating them into shapes. When we consider the structural integrity of metals utilised in defence and aerospace are fundamentally unchanged from historical manufacturing processes, we are overdue for a change. You may ask why. Well, considering the metal industry is the second largest contributor to carbon emissions in the world, not exactly a green and clean industry, that alone is a good reason. So how can we fix this situation? What if I could enhance the performance of metals while reducing carbon emissions? How do we do that, you may ask? Well, Titomic has created the next generation of materials science, utilising all the advantages of modern digital capabilities to unite data analytics and cognitive artificial intelligence with the creative imagination of engineers and scientists. Titomic has created a digital material laboratory of the future that can create over 1 billion combinations of new metals using the full range of elements, both metal and non-metal materials. Titomic utilises a new additively manufacturing process and technology co-developed with the CSIRO, Titomic Kinetic Fusion, that utilises energy stored in all materials to fuse them together by accelerating 5 to 100 micron sized particles at supersonic speeds that fuse them with mechanical bonds as they collide. But we do not melt these metals, so it's a fundamental new way to look at metal manufacturing. Industry and science can now test new customized metal materials for specific performance properties in hours and not years, as has previously been the case. The Titomic Digital Material Lab provides a turnkey systems utilising Industry 4.0 capabilities to provide cutting-edge technology to our customers to find unique value propositions in their product offerings. These new materials are referred to as heterogeneous materials and is a new exciting field of science that will usher in the age of digital manufacturing. Why are we doing this? Titomic is focused on manufacturing made sustainable and creating a clean future for metal manufacturing. Thank you very much.
Biosafe innovations are building antimicrobial solutions that can be applied to fittings, fabrics, as well as existing products that reduce the rates of infections and diseases that are transmitted through contact. The rise of bacterial resistance to traditional antimicrobial treatments, plus outbreaks such as COVID and other diseases, have posed health issues for staff that work in these environments. Our products not only destroy this risk, but also provide long-term antimicrobial protection. With this technology, we have treated PPE, gowns, and face masks and achieved a log7 reduction against microorganisms. We are interested in working with manufacturers to bring this style of product treated this way to market, as it adds minimal cost to produce. Following on from this, we have developed a product for HVAC and ventilation systems that provide similar protection from diseases. We've also applied this technology to water filter media with outstanding results. These claims are backed up with independent testing, and with these products, we've seen a low-cost, low-tech way of treating water to a potable level for immediate use with a single pass-through filter media. Our products are non-toxic, non-corrosive, so they're safe for all applications. This creates an antimicrobial barrier that lasts up to 60 days. This product can be applied from the socks you are wearing today through to day-to-day applications. As I said, we're interested in working with other specialised companies to explore and develop new opportunities for what we see, what we're currently doing. And these are in fields such as plastics, marine coatings, and aviation applications. This process will provide a massive cost savings and reducing any downtime from illness, as well as creating a safe environment for your staff. Thank you.
In 2009, of the 512 coalition soldiers killed in Afghanistan, 280 were a direct result of improvised explosive device attacks. That year saw over 7,200 IED attacks in Afghanistan, a record for the war. As the last troops are being withdrawn, we now face a heightened risk of conflict with near-peer adversaries in our region. Our soldiers may soon be operating in a far more complex threat environment and need more to manage future threats effectively. They need better information, better situational awareness, leading to better decision-making. Currently, vehicle sensor and vision systems are constrained by their physical attachment, and the use of drones requires significant launch and recovery infrastructure, as well as a dedicated operator to detect threats, making them vulnerable to human error. Our proposal is to develop a virtually tethered manned-unmanned teaming system that can provide a dedicated early warning and threat detection capability for vehicles at the tactical subunit level. The standoff automated warning system, or SAWS, consists of multiple autonomous small unmanned aerial vehicles with configurable sensor payloads that can be customized dependent on the threat environment. The vehicle-mounted control terminal provides sensor processing and automated control over the UAVs using secure data links with little to no operator input. By using artificial intelligence, the operator is only required to configure mission parameters such as the expected threats, operational altitude and distance from the vehicle, and the type of search pattern to be used. Scalability in the design allows for the use of multiple drones from the one terminal, facilitating a continuous, survivable capability over the entire mission. As threats are detected, operators receive categorized and prioritized target information in real time, allowing this information to be easily and effectively disseminated at both the tactical and operational levels. Autonomous, scalable, survivable. The benefits of this new system are threefold. Firstly, the level of information available to vehicle crews in complex environments is now increased without having an associated increase in manpower. Better information. Secondly, it reduces the likelihood of ambush from a variety of threats. Better situational awareness. And thirdly, it increases the decision-making time available for commanders, allowing them to react more effectively to an ever-changing combat environment. Better decision-making. Most importantly, this system is designed to increase the safety and the survivability of our frontline soldiers.
Almost every industry report over the last 30 years will tell us that if we're embarking on a large, technically complex project, the chances are that it will either fail outright or fail to deliver around 50% of expected outcome while running over time and over budget. Why after 30 years does this persist? After 15 years of agile practices and a decade of model-based systems engineering, why does this keep happening? One contributing factor is our inability to communicate detail. Our inability to develop this deep, accurate and shared understanding of needs that's necessary to execute and govern large projects. Largely, this is due to the representations of the information we use. Even if we're taking a model-based systems engineering approach, at some point we're going to end up with a database with thousands of requirements, thousands of fragments of information, with only linear traceability to help us in understanding that information. Cognitively, this is analogous to us throwing 1,000 pieces of a jigsaw puzzle on the table in front of people, pointing at that pile of pieces and saying, is this what you want? How much will it cost? How long will it take? This is the poor representation for communicating detail. I'm Dan Powell, co-founder and technical lead of Composition, an Australian company built on 35 combined years of experience delivering large and complex projects in defence and aerospace, transport and government IT. With a team of AI experts and service and support partners providing us a continuous conduit into industry, we've developed a platform that uses artificial intelligence and uses models to effectively integrate and make sense of that large volume of technically complex information to put the puzzle together. This allows us to provide that deep, accurate and shared understanding of needs that's required to execute on large projects. Previous work conducted with Griffith University and Raytheon Australia delivered estimated savings of tens of millions of dollars on individual projects, just through identifying and managing uncertainty at the right time in those projects. Recent work using the platform we've developed is indicating an additional benefit of an estimated 10 times accelerator of the engineering effort that's actually required to develop the requirements and the tests and the architectures in the first place. So if you choose to mitigate risk and cost on your next project, If you want to be put in touch with the people that have done trials with us to hear it from them, if you just want to see a demo, please feel free to contact us on the information below. This is competition. Thank you.
What is the one thing that you never have enough of? Now, some people may say love, but this is a tech session. And the one thing that people don't seem to have enough of these days is lithium capacity, portable battery capacity. And as the batteries get larger, then the charge time to replenish those batteries take a lot longer. Now, what if we could double the charge rate of these lithium batteries that are in your vehicles, the portable ones? What if we could do it 3 times faster? Well, today we're going to talk about 5 times faster. 5 times increase in performance with a product of the future that is here right now. Now, to do this, we had to cast off the legacy mindset of analog designs, and we had to bring in digital technology 5 times faster and at a fraction of the size and the weight. And I'm holding it up here now. A great application of this product is extracting power from an alternator, from a vehicle's alternator. And so, for example, we can extract power from a 12-volt or a 24-volt alternator to a 48-volt support battery all the way to an 800-volt support battery that you may have. Now, we've programmed it to be politically correct, and it is bidirectional, that is. It can flip in seconds, in less than a second, from going from one direction to the other. So that means there's no more flat starting batteries. There's no more single point of failure. You get 10 times the performance, less than half the weight if you have 2 together. CAN bus control, 96% efficient. We've got 3 patents, hundreds installed. Customers are impressed. High-grade reliability, unbreakable, no output fuses required. Throw a spanner across the output circuit, it just stops. Take it off, totally protected. It's designed and developed here in Australia using Australian and USA components. So there'll be a big leap in requirements in the future, and we have the product here now.
Hi, I'm Mike Black, and I'm the creator of RADENET.io. Now, Readiness is a platform that's been built to address the needs of adjusting your assumptions, adjusting your questions, adjusting the outcomes in real time. How we do that is we have created connectivity. We communicate with any platform. We secure the data that we store. We can work on the edge. We don't have to be in the cloud. And we focus mostly on the interoperability and the ability to do things as it happens. So as things change, we can take in that information, and then we can apply natural language querying over the top of that information to give you a better outcome. What we're really looking for here is we've tried a bunch of applications such as in disaster management and understanding the differences of the weather in terms of a standard operating procedure through to disability support. But what we're really looking for is that killer application where it's like, man, that's really using every stack of what we're doing. If it's something that requires complex contextual understanding, if it's something that requires connectivity with devices both on the edge and online, and it requires the ability to be able to take tiny little pieces of information and draw large lines between them and help come up with better questions about the information that you're looking at, better information about the actions you should probably take based on that. That's what we're looking for. I feel that we would love to see what's happening on the other side of the fence to actually work with land forces to help us understand what are the problem statements, what are the things that we can help with this technology stack. We know it can do more. We are looking to push it further than wherever it's been pushed before, and we feel there's an opportunity there to do so.
I'm Annette McClelland, I'm from Tacoma, and we're improving the ways humans interact with technology. Current controllers are overly complex. They're fragile and confusing, actually haven't changed very much in the 80 years since they were invented. My co-founder, Michael Griffin, was testing out trying to fly a drone and control its camera at the same time. He found this so difficult, he thought there must be a better way. So he built one. And he tested against the standard 2-joystick interface for his honours mechatronics thesis at Macquarie University. He received best thesis in control systems. And through that, what we've now developed is a tactile 6 degrees of freedom control orb. It's universal, intuitive, and robust. It reduces the time, cost, personnel, and training required to get jobs done. Here's a demo. I can operate all directions with just 2 fingers. Now, we've been through several different iterations of the controller. With our partners under CRV, we developed an underwater rover controller. Our very first prototype sales were with high school robotics teams, where they had mechanicum wheeled robots that had multi-directional wheels, and they went from taking a whole term to learn to drive their robot to just a single afternoon. And we've tested our controller with thousands of users, from 3-year-olds to 83-year-olds. One student in particular at a STEAM powerhouse demo day rolled up in a wheelchair, right arm in a brace, and I put our proof of concept in his left hand, and he flew a drone for the first time. Wow, he exclaimed, that's really cool. A kid who'd never been able to play Xbox with multiple sclerosis was able to fly a drone. Now, under CRV is our primary customer, and they've actually released units of this rover to customers in the Australian Navy and the New South Wales Police Force. We've also started the process for a universal soldier robotic controller with the Defence Innovation Unit and sold our first units to them just this week. We're really excited to be at Land Forces, and we're excited to see what other ways we could utilize our technology into your applications. The human-machine interface market is set to grow $6.5 billion between 2019 and 2025 in all sorts of industries. We've developed this technology over the last 5 years. Michael and I, a techie and hustler, and we've personally worked on this and done the empathy work to see this technology to light now. What we're looking for today is those partners and collaboration opportunities that can get our technology out there into more applications like it has done with under CRV, robots, gimbals, jetpacks, and more. I'm Annette McClelland. I'm from Tacoma. We're improving the ways humans interact with technology. And we look forward to seeing you here at Land Forces.
Chironix is an Australian company that specializes in applied robotics, autonomous systems, and human-machine teaming. We use the very latest in robotic technology and advanced sensors, which we combine with bespoke software, engineering, and machine learning techniques. We are excited to see a future where humans and machines interact naturally and work together, allowing them to achieve even more as a team. Chironix has a strong focus on the defense market and is involved in a number of cutting-edge projects for a range of military and government users. We understand your special requirements, and our team is very experienced in bringing advanced technology to the forefront of defense capability. Chironix is an Australian distributor for a number of advanced robotic solutions like Boston Dynamics, ClearPath, Agile X, and Google Glass. Our highly skilled robotic engineers conduct integration of these robots with advanced sensors such as thermal imaging and LiDAR. But the real key is getting these robots to work with humans as part of the team. Chironix specializes in building robots with behaviors, allowing them to work autonomously and freeing up people to focus on what people do best. Chironix also makes interacting with a robot simple and seamless. Using technology such as glass, a person can see what a robot sees. We are leading the way with voice recognition for robots, allowing a smart robot to be able to hear your every command. Chironix has previously experienced working with the Australian Defence Force, the Defence Science and Technology Group, as well as the US Office Naval Research. The business has also successfully collaborated with defense primes such as Leidos, BAE Systems, Austal, and Lockheed Martin as part of their global supply chains. Chironix is rapidly expanding to meet the evolving needs of end users requiring sophisticated robotic and artificial intelligence-driven solutions. Contact us today or come and see us at Land Forces to see how we can help your organization prepare for the future. The future is now. The future is Chironix.
In 2018, a US commandant addressed the Marine Corps. He stated that the next fight would be a battle of signatures. We need to assume everything we do can and will be observed. We are going to need to fight to get to the fight, he said. With advancing modernization and digitization of warfare, it is essential that defense embraces low signature technologies. At One Tide, whilst trialing thermally insulating advanced materials, we noticed their ability to mask infrared signature, as can be seen in the slide to my right. The yellow dashed rectangle in this image shows masking of the radiated heat signature from a vehicle that had been traveling for 2 hours. The heat radiated from the wheel and the brakes is completely masked in the footprint of this materials coverage. Following this, we designed a model thermal cloak attached to the exterior of a vehicle to enable rapid deployment and retrieval in the field. The prototype of this thermal cloak provides the ability to mask infrared signature and the capability to protect against electromagnetic pulses and countermeasures and shield EM and radio frequency emissions from vehicles, weapons, and infrastructure. Utilization of this thermal cloak technology could provide the difference between winning the signature battle and future conflicts, and potentially enabling mission success compared to the potential for a national tragedy. Thank you.
Australia's isolation and a diesel supply chain that's easily compromised means we must progress a robust alternative to diesel power generation. Add the complexity of high mobility power and water requirements and increased use of energy-hungry, autonomous and robotic platforms. It's a challenge we have been acutely aware of and tracking since 2016. One Tide have developed the mobile microgrid. Seen here. Lightweight, fully portable, and comes in a lightweight package of around about the 70 kilogram mark. You can get about 20 kilowatts of power into a box this size. It's thermally, acoustic, and electromagnetically silent. Power scalable from 12 volts down here, all the way up to 415 volts 3-phase. All inputs can be taken into the box. Solar, wind, hydro, kinetics, diesel, and even the grid when it's used in UPS mode. Our system compatibility can cover all main segments for defence: stationary base, forward operating base, tactical mobile, and even disaster relief with the water purification module, which you can see here on the right hand side. It's a low power draw unit, which is important when you're using a renewable energy source, and it can produce 12 tons of clean drinking water per day from a brackish or even a seawater source. Mobile microgrid gives defence a stepping stone now to remove the reliance on diesel for all power generation. Harnessing the power available from the environment is low cost and currently on track within the renewable energies industry. Using the mobile microgrid provides massive reduced logistics, OPEX and signature detection, as well as fresh drinking water in a single package. We'll be available on stand 4820 at Land Forces. Please come and see us and have a chat. Thank you.
Think for a moment about the last training session you attended. Was it riveting? How much of it do you actually remember? Maybe not much. And that could have implications for the security of our nation. Unfortunately, although the world's changed in many ways, a lot of education and training still wages war as a death by PowerPoint approach. But what if that training could be unforgettable? What if learning could be almost inescapable? We create educational escape rooms to serve that particular purpose for virtually any topic. What are educational escape rooms though? Well, they take the concept of recreational escape rooms where a bunch of people pay to be locked in the room and solve a whole series of puzzles and take it into the classroom. Now, we use a tabletop approach because it scales a whole lot better than having a whole lot of rooms that you need to lock people in. And we encode the learning modules, whatever they may be, in a series of sealed envelopes that participants open up and go through and solve one by one. They check their answers using the escape room decoder box, and that tells them if they've got the answer right, and it also tells them how long they've got remaining until whatever the narrative might be when the enemy is going to attack or when they need to know what the solution is to find some sort of an antidote or something like that. And has a number of other features like data analytics in there as well. This is what we call an active learning approach, where participants are engaged in their learning and trying to apply the knowledge to solve real problems, rather than sitting back and passively trying to take it in. At La Trobe University, we've used them both for student recruitment and in the classroom. And the reviews for student recruitment have been rave. Students have been loving the activity, and in their surveys, they've said they really want to escape. And in the classroom, we've used it for subjects as diverse as engineering and maths through the biochemistry and health. And each of those areas, we're seeing that students want to solve the puzzles and want to engage in it, not because it's just on the exam, but because they want to learn and want to apply themselves. So, are you looking to take training and recruitment to the next level? Talk to us and see how we can transform training and recruitment for the security of our nation. We can put decoder boxes in your hand, but we can also give you the knowledge and skills to actually encode your learning as a series of puzzles so that learners will remember what they need to know.
Hi, I'm here to highlight the importance and application of a concept called hybrid domain vehicle. Now after we call it HDV, and also propose a feasible path to development of such equipment where I probably can offer my service to you. Let's just start with the definition. What it is, HDV. A vehicle, we can define it as a vehicle. HDV is a vehicle which could operate in both air and water as two important media here. And not only that, but if it's required, that device should be able to quickly and safely and smoothly transit from one medium to another quickly. What are the benefits? Potential benefit could be explained as HDV has an improved ability for handling tracking missiles, all sorts of tracking technology, including tracking missiles, and also could cause confusion, rather confusion with some planned strategy. Also, it's noteworthy to mention that the existing knowledge, hydrodynamic knowledge, could be easily extended and modified for development of such device. What are the general knowledge we have at the moment? We know the space re-entry process, the well-known engineering thing. We know the dual operating missiles already developed and in use. And also we know that recently SpaceX has used this AIVA vectorized propelling system for safe landing the rocket. So all these could be incorporated to the target we have. Technically, we can offer these, and that could be used for development of HDV. We can optimize the propelling system. We can design and optimize the propelling system and the required approach pattern. We can estimate and optimize and improve the impact, the hydrodynamic impact forces, and minimize that, and to define a smooth transition. That would lead us to an optimum body shape design and control design process, which will be the following parts of the process. By going too much of technical this, I want to highlight that this project is inspired by nature and the birds actually, and the core part of this project would be computational fluid dynamics, which have expertise and resources to do that for our client. That's it for the pitch.
All right, everyone, this is the moment you've been waiting for. Today, I'm bringing you a technology innovation that can simultaneously increase military dog health and effectiveness and military capability, all while lowering the workload of military personnel. This project was started after a tragedy with one of the army dogs. Unknown to the handlers, a ball of hoochie cord had been carelessly discarded, which the dog found and, of course, dogs being dogs, ingested before retiring for the night to his kennel. When the handlers arrived at work the next morning, they found him on the floor in visible pain, unable to move with the cord passing through his intestines. On reviewing the security footage, they witnessed he had actually been distressed and suffering the entire night. He then underwent emergency surgery, but was no longer able to perform to the high standards and was subsequently retired from service. Sadly, this was only one of many cases of military dogs suffering over the last 12 months. The Army realized that something needed to be done, and so forged a partnership with Curtin University, where work has been underway over the last several months to use the already installed cameras and advanced machine learning techniques to develop a groundbreaking automatic monitoring system that can identify signs of stress in the dogs from analyzing abnormal behavior patterns that humans couldn't even begin to detect, and no commercial software could match. So far, we've already developed a solid small concept demonstrator where we can track the dogs and some of their basic behaviors fully autonomously through CCTV cameras. We strongly believe this technology will lead to identification and early intervention of stress-related health conditions in canines, preventing significant loss of investment to defense. This innovation is necessary and important, as there is currently no user-friendly method of monitoring the dogs overnight, and often the CCTV cameras are only used after an incident occurs. As they're already installed and set up, it seems obvious to utilize their full potential to prevent incidents. Now, I know what you're thinking. Already underway on this project. What could I possibly do to help make this revolutionary technology become mainstream? Well, while we're already off to a promising start, we are looking for support to expand the scale of the project to other stakeholders and services across defense. If you work with canines, we want to hear from you. Together, we can continue to implement this world-first technology that maximizes existing capability and ensures all dogs are healthy and able to be trained and utilized to their full potential.
If you're collecting and using data to improve human performance, then you're left with two problems. The first one is, what is the most relevant and important data that you need to collect? And secondly, how are you going to use it to improve performance? Our open architecture system has 4 components that work together to create a solution. Firstly, we use sensors on individuals to collect the data. Second, we take that data, analyze it, and identify trends and aberrations. Thirdly, we use artificial intelligence to predict errors and breakpoints, and then we bring it all together with real-time or after-action feedback. This approach is particularly useful for mission rehearsal and preparation for new activities. Within a training environment, you're able to have a closed loop where you can collect the data from the individual teams and process it and feed it back very quickly so that there's a continuous improvement loop and individuals are able to focus on those areas that are particularly problematic in preparation for the mission. Data can be collected horizontally, so individuals, all different ones collecting it at the same time with the same activity, or vertically, where it's the same person, same action at different times. This can create both individual and team benchmarking. Mission rehearsal activities and scenarios are obvious, like a special forces team preparing for a unique and complex mission, or perhaps a medical team preparing for an unusual surgical procedure. Less obvious would be a helicopter repair team preparing for a complex maintenance task. I found that timing of the feedback is particularly important because sometimes it's not helpful to provide feedback in real time as it creates performance anxieties. We're using this approach with NASA and the US Department of Defense, so for preparing astronauts, and with US Defense to help with the prevention of suicide by identifying those at risk and helping to change behaviour. Ongoing human performance in the workplace can also be helped with collecting data and feeding back. More complex in that environment, but we've trialled it and found that it's certainly possible within surgical theatres and mining operations. We keep coming back to those two important points. What is the data that you need to collect and how are you going to use it to improve human performance?
In the mid-2000s, I was a geomedic engineering officer at the 1st Topographical Survey Squadron. I worked with soldiers to create geospatial intelligence, or GeoInt, basically maps to support situational awareness for commanders and soldiers. We had an aerial camera system and also used commercial and classified satellites in the days before Google Earth brought these types of image data sets to the general public. At the time, the Army's drone capability was held exclusively within the Artillery Corps. Their drones also had a camera, but their cameras pointed forwards for surveillance. I had one question for them. What if you turned your camera nadir, or pointing directly down? They said, why would we want to do that? As a geographer or geospatial scientist, the answer to me was clear. To make a map, of course. 15 years later, or 2 years ago, the Army brought 350 commercial off-the-shelf drones into service across the country with the capability of taking nadir or top-down photos. The capability to make maps. This means that soldiers around Australia have an amazing tool at their fingertips to capture the data needed to make the most detailed map of our country. What if we had soldiers from every Australian Army unit flying systematically, consistently, and then contributing their data to a central repository? In my time as a troop commander, I attended an ADF forum to discuss, among other things, the value of GeoInt at the time and the forecast into the future. Commanders presented their exciting outlook for new imagery and mapping data that was coming online. I had one question for them. Would there be a central repository where we could archive, search, and integrate the data that would form the basis of GeoAI? They said, that's a great idea, but not yet. We have more data, more tech, more artificial intelligence now than ever before, but unless we have a central repository, we can't hope to harness their full potential. GeoNadir is the Earth from above. We are building the most detailed map of the planet ever possible using crowdsourced drone imagery. We use the centralized data to build deep learning models with a capability to detect features in the environment and track how they change over time. Machines aren't born with artificial intelligence. Like humans, they need to be taught. We use nadir drone imagery to teach machines situational awareness and advanced scene understanding to support battlefield and humanitarian areas of operation. That's GeoAI for commanders, and that's GeoNadia.
Hello everybody, my name is Christian Fulton. I'm the Business Development Manager at AIVA, an AI-driven automated assessment platform that has been proven to drastically reduce training times, training costs, while improving learning outcomes. However, before I get into the technology any further, I'd like to paint a quick picture for you all. In March 2019, there was a crash of a Boeing 737 MAX 8, the second in 6 months. Direct costs of these crashes to Boeing were over $20 billion US, with 450 planes grounded for almost 2 years and a collapse in customer confidence, adding a further $67 billion in lost revenue for Boeing and another $120 billion in flow-on losses to airlines and suppliers. Analysis of the flight data showed the issue to be a failure to train pilots on new systems. Similarly, in 1970, Apollo 13 suffered an explosion while on the way to the moon that vented contents of the service module's oxygen tank into space. Now, without oxygen for breathing and generating electricity, the service module's propulsion and life support systems could not operate, forcing the crew to transfer to the lunar module as a lifeboat. In the end, the spacecraft was successfully recovered and all 3 astronauts made a safe return to Earth. Now, the handling of this incident has largely been attributed to the additional 1,000 hours spent training over previous astronaut crews, and it is widely acknowledged that both the Apollo 11 and 12 crews would not have been able to deal with this incident due to lack in part of their training. The same attention to training has allowed 242 astronauts to build and maintain the $180 billion International Space Station, which operates 400 kilometers and 2 days from the nearest rescue, with only a single minor incident in over 22 years. So we have a grand challenge. With an aging population and the rise of automation, the world will need over 415 million people to be retrained in the next 15 years. Similarly, as the war space becomes more varied and the avenues and methods of attack more broad, defense needs to adapt to meet the rising challenges that emerging technologies bring. Unfortunately, traditional training has only an average success rate of 37%. AIVA integrated training has a success rate of 90%. AIVA was originally designed and built for NASA and is now used worldwide in both defense and commercial training applications. AIVA directly links training data to learning outcomes and provides trainers with intelligent virtual aids that allow them to train and assess entire cohorts of students with greater precision and efficiency than even traditional one-to-one training. AIVA can even use its intelligent AI systems to automatically assess learning outcomes in real time, allowing trainers to focus on high-level outcomes while AIVA conducts micro-assessments. AIVA can capture any type of data format from video feed to biometrics and can do so from within any simulated or even real-life environment while making all data available for after-action review. AIVA has been used in both the Australian and US Defence Forces, including multiple deployments with the US Air Force, where it has helped reduce their pilot training costs by over 70%, cut down their pilot training times by over half, 52 to 24 weeks, and increase their first flight success rate from 5% to over 80%. AIVA can be integrated into any of your existing training platforms to drive your training dollar further, faster. Thank you very much for your time. Please feel free to get into contact with me directly, and do come see us at our stand 4G2 throughout the conference. Thank you.
What if I told you that we do imaging wrong? There's a proven and better way, not just to sense the visual world, but to perceive it. This is not a camera. That pointed me there is a camera. This may look like a camera, but there's an important difference because what you're looking at here is a biology-inspired visual sensor, and it offers a whole new way to approach seeing the world around us. But why look to biology for solutions? Well, simple really. Biology has come up with a much better solution already. From the beginning of their evolution 550 million years ago, nervous systems have been under intense selection pressure for optimal speed, power efficiency, and precision in noisy and dynamic environments. And it so happens that the environments that conventional cameras and computers struggle with most are noisy, dynamic, and time critical. So it's these 3 operational requirements that have sculpted every aspect of biological sensing. And with that, let me introduce you to a field of research known as neuromorphic engineering, which aims to understand how biology does sensing and computation, and to use those techniques to solve real-world problems. I'm Greg Cohen, an associate professor here at the International Center for Neuromorphic Systems at Western Sydney University, and we design and build neuromorphic sensors like these. Sensors that work in a completely different way to conventional cameras. These cameras are unique in that they have no frames,
no exposure times, no saturation effects, and don't suffer from motion blur in the same way. If you take one of these sensors and point at a static scene, you get no data out. Only when something moves in front of the camera do the effect pixels send you information, and they tell you exactly where in the field of view that motion is happening. Compare this to a conventional camera, where we have to pull frames out at a fixed rate, regardless of what's going on in the scene. By contrast, these cameras push data to us, and only when something happens. This makes these cameras low power and low bandwidth. They also overcome lots of the problems associated with conventional cameras, because much like our eyes, they can work across a wide range of illumination. So, what do we do with these sensors? Well, we can build fast, reactive, and mobile systems that can be worn and integrated into clothing and equipment due to the small form factor and low power requirements, and systems that can operate whilst in motion continuously and while moving through busy and cluttered environments. And we can do things that are almost impossible with conventional cameras, like seeing through gaps in trees and bushes as we move the camera, using parallax to see what's on the other side of the obstruction, much like how we as humans can walk past a white picket fence and see what's on the other side through the slats as we're walking. We've also shown that we can do tasks like bullet detection really well. We can defeat camouflage because we can pick up the motion. They're fantastic for muzzle flash detection and any sort of high-speed tracking tasks, all at low power and at high speeds. And over the last 4 years, we've applied this technology in other domains with lots of success, primarily in using these on satellites and to look at satellites in space. We proved both the science and the practicality of this technology and are looking to apply it to other extreme sensing environments. This is our future for imaging, and it's here now.